Hey guys, I'm Janelle, and I'm going to show you how to use matrices and Gaussian elimination to solve a system of linear equations. Gaussian elimination is like puzzle solving, and every puzzle is going to be different. I'm going to show you the rules and how to use them. The bad news is that there isn't a single set of steps that works every time, but the good news is that you're about to get better at this, so let's do it! Before you can start solving systems of equations, the first thing you have to do is rewrite the equations as a matrix. So, if you have some equations, it helps to write the equations so that all the variables are in the same order. Just makes it easier to see what's happening. I wrote these in the right order because I didn't want to waste your time. I'm just saying look out for that. So, let's make a matrix. So, each equation has three parts: the coefficients, the variables, and the value that the equations equal. We're basically going to copy each equation into a row of the matrix. Each column is part of the equation. These columns are the coefficients for each variable, and the last column will be the value the equation equals. Basically, we're just copying stuff here. I'll start with the coefficients. These are the coefficients from the variables. If a variable doesn't have a coefficient, the coefficient is actually just 1 because you have one of that variable. That's why I wrote 1 here. Also, if a variable is missing, you put a 0 in its place because you don't have it. So we're missing the y variable here, which is why I put the 0 there. Now this last column, these are the values the equations equal. It makes it easier if you put a line before the last column, just to separate it out. You don't have to. It's not math or anything, it's just to help people remember what's going on. Now we have a matrix, so what are we even trying to do to it? So how do you solve this? Well, the goal is to make the matrix look like this. I know this seems weird, but if you make the matrix look like that, you've basically solved the equations. So, where these dots are, you'll have numbers, but everything in the lower left corner needs to be 0. So, in the last row, you should have all zeros except for 2 elements. And as you go up, each row has one less 0 in it. So I'm sure you're wondering why. Because remember, each column represents a coefficient for a variable from the equations. So what we're really trying to do is reduce the equations, which will make them super easy to solve later. So now, how do you make the matrix look like that? So, to get the matrix to look like what you want, there are basically 3 things that you can do. The first thing you can do is swap the rows around. Not the columns, just the rows. You can change your order around to try and get closer to what you want. So here, I swapped the last 2 rows. Second, you can multiply a row by a constant, so long as that constant isn't 0. You just multiply every element in the row by that constant. So here I multiplied the second row by 2. And since fractions are constants too, you can multiply a row by a fraction if you want to divide it. Finally, you can add or subtract one row from another row. You just add or subtract the elements in the same columns. You can even add or subtract a multiple of a row. This is really, really useful. And remember, you're only changing one row when you do this. Now you know what you can do. I'm going to show you the craziness in action. So here are some equations. I'm going to start by making the matrix to work on. So remember, the goal is to get everything in the lower left corner to 0. If you can do that, you can start substituting and solving. So how do you know where to start? Well, there isn't really any one right way to do this. You try anything that you think will get you closer, and if it doesn't work, you can always go back and try something else. If you see something where you can knock it out and get a 0 where you need it, that could be a good starting point. Like with the 1 here in the second row. So I subtracted the first row from the second. This got me a 0 in the first column. Okay, that was easy to spot. Now I'm going to do the same thing for the third row. How? Don't forget you can add and subtract multiples of rows. So by subtracting a multiple of a row, I knocked out the first column of the third row. So we're getting there. So the last two rows have a 0 in the first column. This is really good because anything I do with just those two rows, the result in the first column will stay 0. So I added a multiple of a row again. I added 2 times the third row to the second row. And now I have a row with 2 zeros in it, so I can just swap that to the bottom. And here we are. We have the lower left corner zeroed. So I did it in only a couple of steps because I didn't want to go crazy on you, but it may take you more steps to get there. I mean, whatever. As long as you get there, you get there. And I worked this out so it stayed all nice with whole numbers, but that's not realistic. A lot of the time you're going to end up with fractions, but that's totally fine. So I created a matrix from the original equations, and now to solve, I'm going to do the opposite. I'm going to create 3 equations from the matrix. So the columns left of the line are still the coefficients of the variables. And so we get 3 new equations. Because of those zeros in the matrix, some variables have been knocked out, and now these are very solvable equations. Starting with the bottom equation, we'll solve them working our way up. So z equals 1, and because there are only 2 variables in the second equation, we can substitute the value of z in to figure out the value for y. So y equals 4, and finally we substitute y and z into the first equation to solve for x. And that's it. It was a long, strange trip through the world of matrices, but we solved all 3 equations. I really hope this helped you understand how to do Gaussian elimination. I know it's a lot to wrap your head around, but just remember, you don't have to do it alone. And if you don't like math, it's okay. You don't have to, but you can like my video. So if you did, please like or subscribe.